we've already talked about how to do these by hand. I want to show how you can do them using the calculator. So for this first one, right here, okay, if you just start off by typing the function as it appears, and I'm going to use function notation. You can, generally you can use either y equals or f of x equals. The ability to use function notation is helpful when you want to evaluate. And so for this one, we're evaluating for f of x plus 6, so it's useful to have that first. Okay, so again, notice all I do here is I type that in. When I type it in and scroll, okay, I can see where the graph is. So I scroll out, zoom out so I can see it. And then the next thing I'm going to do is I'm going to just type this next function. I'm going to give it a different name, so I'll call it g of x. Okay, and notice g of x is equal to the f function with that horizontal shift if you're working with the specifics of it. But once you type that in, you can now actually see, in my case it's the blue graph here, you can see what the x and the y coordinates are. And so the question's asking for what value of x does this reach its minimum? If my point's -11 and 106, notice both of those are options here, right? Okay, that probably tells you that you're on the right track, and you will likely see common distractor answers that are part of the calculations. And so here it's just a matter of which one do you want. It says which value of x, so we're looking for the x coordinate, which is -11. Right. I want you to try or actually let me remind you here of this next problem, and then I'll have you do the two on the right. Okay, so we've talked about linear regression, right, where you create the table, you enter two sets of points, two-ordered pair, and it will give you the equation of a line. And you always need one more point than the power of your function. And so when we're looking to evaluate this, it's a quadratic function. So the power of a quadratic function is 2, or the degree of it is 2. We need one more than that. So we need 3 points in order to create a table here. So for this problem right down here, I'm given 2 points, right? I'm given the point -6, 3. So I'm going to enter that. So -6, 3. Again, I entered this add table. My next point, it tells me that an x-intercept exists here. Well, remember, an x-intercept means that the x-coordinate of -53/4 is associated with the y-coordinate of 0. So that is an x-intercept. So if I type that in as well, I get a second point. So notice again right here, what I have is I have these 2 points that are showing up in my graph. And so I want to find a parabola and identify what is the other x-intercept. Well, in order for me to do this, I need a third point, but I don't have the coordinates. Now, there is a way that you can calculate it based on the intercepts and how they relate to the vertex, but I'm just going to show you how to do this visually. So if we put one of those intercepts, I'm going to call it P or Q, right? When we use, those are the letters we use for x-intercepts. So if I say P0, and then I enter P so that I have a slider, right? So this is just creating a slider for me. I'm going to say P equals 1. I don't need the 1 there. But what I want to do is I want to see what would this function look like based on the number where I can, and I'm going to choose either 5/4, -41/2, 17/2, or 53/4 for my P value. So I'm going to test all of those possibilities to see which one lies on the graph of a parabola. So I do need to see what that graph looks like. If you recall, the way that we pull up the regression is we call it Y1. Okay, and we use the similar to symbol. And then we write in our equation or our function. Okay? And so when you are writing this, you can use any of the forms. It doesn't matter. The general form, a x1 squared plus b x1 plus c. And now notice that I have my graph of this parabola. And now I'm looking to see which of these points right here falls right on this graph. Well, it looks like 1 is relatively close, but let's just test our points. I'm going to start from the bottom up because I already know what the answer is, and I want to show all of the possibilities. So if I start with 53 over 4, notice where that is here. Okay, 53 over 4. If I use this as my intercept, do I have a vertex at negative 6, 3? No. I need my vertex to be right here, right? That's the point that they gave me. So in order for this to happen, I need this to be the vertex. So 53 over 4 is not the right answer. Let's take 17 over 2. Again, is this the vertex on this function? No. So I test the next negative 41 over 2. Okay, now, again, it's not the right, this is not the vertex. And if I test the last possible 50 or 5 over 4, now do I have a vertex here that I'm looking for? Yeah, the negative 6, 3 is my vertex. So by testing those points in the graph, you're able to see what the answer is. Right, I want you to see if you can answer the remaining 2 questions on this slide, here and here, using the desmosC calculator. So the approach on this is just like it was for the linear function, a linear regression. It's just like what we saw on the previous problem. You need to enter your table, and you're just copying the table that they give you. They give you 3 points. So if we hit the add item and choose table, and we plug in the 3 ordered pair that they give us, negative 1, 7, 0, 9, and 1, 13. Once you do that, you can choose any of these 3 forms. These are the 3 forms of quadratic functions, right? General, vertex, and intercept forms. Since all of the answer choices are general form, that's the form I'm going to use. So y1 is similar to, brings up regression. And then it's ax1, make sure you remember the subscript 1s, squared, get out of the power, plus bx1 plus c. And it gives you your parabola, your graph. Okay, and then notice here, it gives you the a, b, and the c value, the coefficients here for each term. So 1, 3, 9, so we're looking for the one that goes 1, then 3, then 9. And so that's this last option, option D for this problem. Okay, the last question here, super simple. You should be able to answer this last question by hand, like quicker than what it's going to be by the calculator. But if for some reason you forget, simply type it in exactly as it appears. So f of x is equal to x minus 6 and x times 4. And you're looking for the x-intercepts, and so you can just click right on those, and you see that negative 4 or 6. Okay, and again, this is asking what is the x-coordinate of an x-intercept. It doesn't say positive or negative, so you can choose either one, and you would get it correct. All right. The next slide is something that we haven't even talked about, okay? And we're not going to. You'll talk about this in Algebra 2. Okay, but there are nonlinear functions beyond the quadratic functions that you are going to have to be familiar with by the time you take your SAT. And one is exponential functions, but let's say you don't even know anything about them when you take it, because it is possible if you take it next year in the spring, you might not have covered exponential functions. I'm just now getting to that in my Algebra 2 classes. Okay, so it's possible that you'll take this test if you take it as a junior before you cover it. So you should still be able to enter the function just like you see it. 330 times 0.2 to the power of x. And it gives you that function. You see the graph of it. Okay, now here you're just evaluating it anyway. So if we take that f of 0, type in the function notation, it gives us our answer of 330. And if you do study this or you get exposed to it before your test, you will probably be able to solve this more easily by hand than entering it, but it's still a possibility. All right, the second one is harder, and again, I'm going to kind of lead you through this. You see that you have this value when you plug in 4 to the function, and you know what the value is going to be. But what you don't know is what the base of the power is. Okay, so if we just type the equation exactly as it appears, so g of x is equal to 18. You don't need the times, but I'm going to put times a to the power of x. Notice it prompts you to add a slider. We're going to do that. Right, and so what we're going to do is we're just going to use some trial and error here to find what a is. And the way that we do that is we know that g of 4 is equal to 1458. So if I evaluate g of 4, notice it's 18 when a is 1. So if I just start scrolling through my slider here, so I look to see, do I need to go to the right or to the left to make this number right here bigger? Because I need this number to be the 1458. So as I slide, I see it's getting bigger, so I'm going to keep going. Notice I'm past 1458, so I'm going to come back. Right there, I happen to land right on 1458. So here's my answer, 3. Okay, so this is this is the a value. So let me go back here. Okay, so this is your a value. Okay, we haven't solved the problem yet, but we found our a value. So what we can now do is once we find what our a value is, we can come back up to this equation, and we can replace a with the 3. Okay, although you can leave it right here. I mean, it's already replacing it with the 3, so actually we don't even need to do that. But the actual final answer is, or the final problem asks us, what is the value of g of 3? So if we now evaluate g of 3, we get the answer we're looking for, and g of 3 is going to equal 486, and that would be actual answer for this problem. All right, a couple more types of questions involving the nonlinear functions. If we look at the next slide. Okay, the next one has a graph of a function, and again, you will learn the rules for these later of like how do you know when it goes up or down, how do you know what happens when it crosses the x-axis here, here, and here. Okay, you will have rules for those next year. But for right now, all you can really do to solve this question, if this is all you know up until what you've been taught so far, is just type each of these functions in and see what the graph looks like. Find the one that looks the most like this. So if I just start typing all of these in, so negative 1 over 10 times x squared, and then x plus 4, and x minus 6. It has the same shape, right? But it doesn't bounce off of the x-axis right here. So I know that that's not it. I'm going to go ahead and keep moving on. So y equals negative 1 over 10 times x minus 4 squared, and then times x plus 6. So I'm going to hide this function because I know that was not it. And notice this one goes too high again. It doesn't bounce off right here at the at this factor of negative 4. So I know that's not it as well. So I'm going to go to my next one. Negative 1 over 10. Here I have x squared, and then x minus 4 and x plus 6. Again, it doesn't bounce off here, so that's not it. So I've checked all of those. By process of elimination, it has to be the last one, but let's go ahead and verify that that's the case. X times x plus 4 squared, and then x minus 6. Does this one have that same pattern? Yes, bounces off negative 4, comes down, and then passes through the origin 0, 0. It goes up at 4. So 4 I see here, and then it passes through again at x equals 6, and so I can see that that does as well. So here is my final answer. I see that it fits the form of this last equation, and so that would be my solution. So even if you haven't been taught this, these rules, you can still solve this. All right. This last one, I want you to see if you can try this on your own. See if you can answer this. You can either It can be solved by either writing it as a system of equations. It can be solved as writing it as a single equation. And so there's a couple different options you can use. I want to see if you come up with one and see if you can find what that answer would be if you don't really remember being exposed to a question like this. Can you create what's needed to help you answer the question correctly? Okay, so I'm going to show you the way I would see this. If I didn't know how to set it up and solve it by hand, what I'm going to do is I'm going to just take a look at what I have. It says the product of two possible integers is 750. So I know that A times B equals 750. Okay, it says that the first integer is 20 greater than twice the second. So A is equal to 20 greater than, I'm adding 20 to second, something, twice the second. Well, the second one is B. Okay, so what I can do right here is I can simply take A times B. I want to add both of those as sliders, or actually I'm not going to add sliders because I know what A is equal to. I'm going to say that A is equal to 2 times B plus 20. So notice that's based on this equation. So the only thing I need to know is I need to assign values to B. Well, I know B has to be one of four things, right? B is either 100, 7, 15, or 50. So I'm going to test each of those. If B is 100, what is A times B? 22,000, is that what I was looking for? No. So I'm going to test the next one, 7. When B is 7, A times B is 238, is that what I was looking for? No. So I'm going to test 15. Here, A times B is now 750, is that what I was looking for? Yeah. So by trial and error, when you use that slider to plug in points, you're going to get your answer that way. Okay. So be aware of how the different pieces relate to each other, and you can come up with the solution without even knowing how to solve it mathematically. And let me talk through one of the mathematical solutions, though. Okay, so if you know that the product of two positive integers is 750, this time I'm going to use x's and y's, but it's the same thing. So x times y is equal to 750. It says the first integer is, so x is going to be 20 greater than twice the second integer, so 2 times y. Now, I have this equation now where I just replaced x with an expression for that. And so now if I type that in, I would get my answer for y. If I do it this way, though, I have to look for where the y, what the y coordinate is. So I'm going to just turn these into x's. If I have a single equation, I'm going to solve it for x. So basically, it's like I said, I'm saying x times y is equal to 750. Everything stays the same. I'm just using a different set of variables. So 2x plus 20 times x is equal to 750, and that gives me my solution. I see that it's 15 right here. If I zoom out, I'll find that there's another solution, negative 25. But notice here it says the product of two positive integers. So the negative 25 isn't going to work for this one because it doesn't fit that condition. So you can, if you understand that as well, you can solve it mathematically, and the calculator will make it easier and quicker to answer that question. All right. So these last two questions here of nonlinear functions are a little bit on the harder side because this first one, normally what you would think here is I just need to type this in, right? X squared minus 8x minus 2 equals 0. And I see that my answer is 8.243 or negative 0.243. Okay, so if I wanted to, I could plug each of these numbers in 4 plus the square root of 6, 18, 12, or 22. And I can test to see which of those values is equivalent to either 8.243 or negative 0.243. So that is one way that I could solve this. Okay, and you can do it that way, not a bad idea. I want you to, part of the reasons for learning how to use desmosC is that you can take advantage of what it does. the slider on desmosC is what makes it unique. And so even if you're familiar with TI-89s, which are powerful tools also and allowed on the SAT, knowing how to use the slider can make a problem like this even easier. So if I know that my answer is 4 plus the square root of k, I hit 4 plus the square root of k, and I use a slider for k. I know that k has to equal one of these numbers. So I'm going to test 6. Notice, is this equal to the number I was looking for, 8.243? No. So I then type in the next number, 18. Is that equal to the number I was looking for, 8.243? Yeah, there's my answer. So 18 is your solution. So notice, again, when you can use a slider and just test the different points, it will make your solving the problem very quick. All right. The next question, again, understanding how the calculator works is going to be helpful for this, because if you just type in your equation, now you can either type in ABS as an abbreviation for absolute value, or you can come down to the drop down and choose the absolute value symbol. Either one is fine. Okay, but if I take the absolute value of 8x minus 8 is equal to 192, notice it does give me my answers, but I can't really see where these are. Okay, I can zoom in and I see that it's 1, 2, it's somewhere between 2 and 3 here, but I need to know an exact answer, so that's not necessarily going to help me. Okay, we have a couple different ways that you can do this. One is if you turn this is solving for the equation, but if you turn this into a function where you put this all on one side, so if we subtract 192 from both sides, 192, and this becomes a 0, right? Oops. And then if we just replace this with a y, that's going to give us our equation, and once we have the function for this, we're looking for the zeros. So the two answers are 25 and negative 23. It wants the positive one. So here x is equal to 25. Is our answer 25? Guaranteed the most common mistake is going to be to write 25. You do everything right, but you don't realize it wants x minus 1. So 25 minus 1 is what it's actually looking for. And so your real answer needs to be 24. So be careful on something like that. All right, I want you to try this last question on your own because we've dealt with linear systems. There's no difference here. This is also, you can do systems of nonlinear equations. So I want you to see if you can solve that on your own before I talk through it, this final question. Okay, and so for this, you have this equation, 3x plus y equals negative 15. There's my linear equation, my line. I also have this quadratic equation. So 3x squared is equal to y plus 411. And so notice it wants the it says here which of these is the solution. So when you look at these two answers, okay, you see that the answer is either negative 12, 21, or 11, negative 48. Notice how many of these values, only one of them is the right answer, but notice how many appear. Negative 12, 21, 11's not there, but the opposite of 11 is. Negative 48, so you can kind of see the structure of their distractors here. It wants what's one possible value of x. It's either negative 12 or 11. The only one of those that I have is negative 12, and so that would be the correct answer for that problem.